As a child, I often found myself gazing at the stars in the clear night sky, my imagination soaring beyond the twinkling points of light. You see, the idea of time travel always fascinated me. It felt like dipping my toes into a pool that held endless possibilities. Now, you might be thinking that time travel is the stuff of science fiction, reserved for blockbuster movies and epic novels. But what if I told you that science, real science, gives us a glimmer of hope that time travel could one day be possible? Let's embark on a journey, shall we? Imagine a river flowing gently through a lush green valley. That river is time, constantly moving forward, carrying us from one moment to the next. But what if, just like a river, time has hidden bends and loops? What if there are ways to slip through its currents and emerge at a different point along its path? In the world of physics, there's something called Einstein's theory of relativity. Now, this might sound a bit complex, but stick with me. Einstein's theory suggests that time can be stretched or compressed, just like a rubber band. And this stretching or compressing of time is a key part of what could make time travel possible. Picture yourself in a spaceship, racing through the vastness of space. As you zoom closer and closer to the speed of light, something incredible happens. Time slows down for you. It's like pressing the pause button on a stopwatch while the rest of the universe keeps ticking away at its usual pace. Imagine that. By traveling really fast, you're effectively traveling into the future, as more time has passed outside your spaceship than inside. This concept is known in science as time dilation, and astronauts have actually experienced it. For instance, when astronauts spend time aboard the International Space Station, orbiting Earth at high speeds, they age just a tiny bit slower than we do down here. It's a minuscule difference, but it proves that Einstein was onto something. Now, you might be wondering about traveling back in time. That's where things get even more intriguing. Imagine a path through a dense forest. It's winding, mysterious, and you can't see where it leads. Theoretical physicists have pondered the idea of wormholes, sort of like secret tunnels in that forest of time. Wormholes, if they exist, could potentially connect two different points in time and space, allowing us to step from one moment to another. To envision a wormhole, imagine a piece of paper. If time and space are represented by this paper, a wormhole would be like folding it so that 2 points touch. You could then pass from one point to the other without journeying the entire length of the paper. It's mind-boggling, isn't it? Let me tell you a little story. When I was a teenager, my friends and I stumbled upon an old, abandoned house in the woods. As we explored the creaky floors and dusty rooms, it felt as if time had stopped in that place. Everything was frozen in a moment from the past. That sensation, that whisper of nostalgia, is what wormholes might feel like, providing a bridge between moments long gone and those yet to come. But before we get too carried away, let's touch on reality. Wormholes, sadly, remain purely theoretical. While they make for captivating ideas, our current understanding of physics tells us they're unstable and would collapse too quickly for anything to pass through. Yet, the notion of wormholes sparks the imagination and fuels scientific inquiry. Maybe one day, a breakthrough will illuminate a path through time's mysterious forest. Now let's explore the notion that time might not be as linear as we think. Some scientists suggest that time could be a bit like a vast ocean, with waves and currents moving in all directions. If that's true, then perhaps time travel isn't a journey through a straight line, but rather a dive into a sea of infinite possibilities. To bring this idea closer to home, think about the smell of freshly baked cookies, the kind that takes you back to your grandmother's kitchen, filling you with warmth and nostalgia. That sudden recall of the past, triggered by smell, is a small-scale time travel of the mind. It shows us that time might not be something we just march through, but an ocean of experiences we can dip into again and again. So where does this leave us? Time travel, while still a mystery, invites us to dream, to explore, and to question the nature of our reality. Each tick of the clock is a reminder of time's relentless march, but also of the adventure that lies in understanding it. As we reach the end of our journey today, I leave you with this thought. Maybe time travel is not solely about machines or wormholes. Perhaps it lives in our imagination, in the stories we share, and in the memories we cherish. By rediscovering our past and dreaming of our future, we travel through time in our own unique way. And who knows, perhaps one day science will catch up with our dreams, and the stars I once gazed at as a child will become the destinations of tomorrow. Until then, let's keep wondering and dreaming. So, there I was, sitting under a starlit sky, wondering if time travel could ever be more than just a fantastical plot in my favorite science fiction movies. I remember as a kid, I would dream of hopping into a time machine, visiting the dinosaurs, or peeking into the future to see if we'd finally have those flying cars everyone keeps talking about. Those dreams sparked something in me, a curiosity to understand if time travel might actually be possible. Let's dive deeper into this fascinating topic. According to physicists, time travel, at least theoretically, has some basis in the reality of our universe. This notion primarily stems from Einstein's theory of relativity. Einstein proposed that time is not a constant, rigid entity, but something more flexible, a dimension that can be bent, much like space. Imagine time as a river, flowing serenely, but capable of twisting and turning under the right conditions. This brings us to the concept of wormholes. These are theoretical passages through space-time that could create shortcuts for long journeys across the universe. Think of them as tunnels. You're driving through a mountain, and instead of winding around it, the tunnel cuts straight through. Now, imagine this tunnel connecting different points in time. Mind-blowing, right? However, as exciting as wormholes sound, they remain purely speculative. The challenge lies in their stability and our current technology, which simply isn't advanced enough to create or maintain one. Another intriguing idea is time dilation, which comes into play with Einstein's theory too. Time dilation suggests that the faster you move through space, the slower you move through time. It sounds strange because, in our everyday lives, time feels constant and reliable, ticking away at an unchanging pace. But in the realm of physics, particularly at speeds approaching the speed of light, time can warp and stretch. Here's a simple example. Imagine you're on a spaceship traveling at near light speed. Back on Earth, a year passes. For you, on that spaceship, perhaps only a few months have gone by, because your high-speed journey has effectively slowed down your experience of time. So if you return to Earth, you might find that everyone has aged more than you have. It's like a real-life version of time travel into the future. Reflecting on all this, I often think about the practical implications, the real what-ifs. If time travel were possible, how would it change our understanding of history? What ethical questions would arise about altering events in the past or peeking into the future? Would it bring us closer as humans, or would it create new divides based on when in history or the future we decide to dwell? As I ponder these questions, I realize that time travel, at least for now, is more than just a scientific pursuit. It's also a philosophical one. It urges us to reflect on our existence, how we perceive the past, and our hopes for the future. Even if we never achieve time travel in the literal sense, the desire to understand and explore these possibilities drives innovation, pushing the boundaries of what we know. So, as I gaze up at the stars that have inspired countless tales of time travel, I am reminded of the age-old human quest for exploration. While we might not yet have the means to bend the river of time, the journey of discovery is just as thrilling. And who knows what the future holds? Maybe one day, time travel will step out of the realm of theory and become a reality, offering us a new frontier to explore. So, Picking up from where we left off on our journey through the theoretical possibilities of time travel, let's dive a bit deeper into wormholes. Now, wormholes are fascinating. If they exist, they're like tunnels in space-time. Imagine a giant tube connecting two different points in the universe. You enter one end and pop out on the other, possibly millions of miles away or even in a different time. Albert Einstein and Nathan Rosen first came up with the concept back in 1935, calling them bridges. But as cool as wormholes sound, they come with their own set of challenges. For starters, they might not be stable. Picture trying to keep a tunnel open in the middle of an ocean. The water around it wants to close in, just like the forces of gravity might want to close a wormhole. To keep it open, you'd need something called exotic matter, which has negative energy density. It's like a magical force that could hold the tunnel open. But right now, exotic matter is more of a theoretical concept than something we can actually use. Now you might be wondering, what would it be like to travel through a wormhole? Well, if it were possible and safe, it could mean instant travel across vast distances and maybe even stepping into a different time. Imagine visiting ancient Egypt for a day, or jumping forward to see what the world looks like 1,000 years from now. The possibilities are both thrilling and mind-boggling. But here's something fun to think about. What if you're in the future and you meet your future self? There's this interesting idea called the grandfather paradox, which challenges how time travel would work with cause and effect. Let's say you went back in time and accidentally prevented your grandfather from meeting your grandmother. That would mean you were never born, right? But if you were never born, how could you have traveled back in time in the first place? It's a puzzle that scientists love to ponder. I remember when I first learned about the grandfather paradox. It was during a college lecture, and the professor asked us to think about all the different outcomes that could result from changing past events. I spent hours afterwards with friends at a local cafe, scribbling down ideas on napkins, trying to make sense of it all. We came up with crazy scenarios and laughed at the absurdity, but it made us realize how complex and interconnected everything is. Then there's another idea known as the many worlds interpretation, proposed by physicist Hugh Everett. This one's a bit like something out of science fiction. It suggests that every possible outcome of an event actually happens, creating a vast number of parallel universes. So if you went back in time and changed something, you'd create a new branch in the timeline, leaving the original history intact in a separate universe. Think of it as a cosmic, choose-your-own-adventure story with endless possibilities. These concepts make us reflect on the nature of time itself. Is time a straight line, a circle, or something else entirely? And what does it mean for us, mere humans, trying to find our place in the universe? As we ponder these questions, it's important to remember that, while time travel is exciting to think about, it's still highly theoretical. We're not close to building a time machine just yet, but exploring these ideas pushes the boundaries of our understanding and sparks our imagination. Who knows where these thoughts might lead us in the future of science and technology? So as we continue to unravel the mysteries of time and space, let's keep our minds open and curious. After all, the universe is a vast and wondrous place, full of secrets waiting to be discovered.